which, by the way, if you didn't know, pretty much all the data sets in your textbook and a lot of the data sets that are actually on the AP statistics exam are from real life situations. I will say that on the AP statistics exam, they have been probably manipulated enough so they don't even look like the original statistics, but they do come from an original, like a real life data set. All right, so as of now, you should have entered your C's into the Google form, and just hold on to that airplane tickets one. If you didn't know how to do it, it's okay. We will get to that, maybe today, maybe not. Everybody has the season, yes? Rourke, do you have the season? Okay, good to know. All right. So here are the answers to the C's. Egg, boy, boy, cat, cat, dog, dog, cat, dog, cat. In case you didn't get those. And we will go over those because there's some that were relatively important to look at. And after you have that all ready to go, then you should put your devices, unless your Will or Mr. Kale, he can have his device still to see the front board, but just not to play whatever that is, 4, 2, 4, 8, 16, whatever. So as long as you're using it for class and not for entertainment. Aren't I entertaining enough? I try to be. I mean, my kids and my adult friends would sit in the room and just probably pee their pants laughing so hard at some of the things I say and do. Like, seriously, Garrett? That's how you act in your classroom? Well, gotta keep them awake somehow. Okay, so today is all about remembering or maybe learning for the first time. And we are going to play this game. I think maybe these are changed, but Caden and Ainsley would know who they are, but I think we changed them for this fall. So the rest of you should be able to play without knowing who's behind here. All right, so I want you to name the person. I'm telling you they're famous. Anybody want to take a guess? Anybody else? Not LeBron. All right. They're Caucasian. Anybody want to take a guess? It is not him. It used to be, but Heather and I honestly just couldn't do that, so we changed. Anybody else? It is not Mr. Trump, not President Trump. It is a male person, though. Anybody? Any guesses? This person's pretty famous. It's not Tom Cruise. They are a politician. It's not Joe Biden. It's not Bernie Sanders.
George Bush.
It's not George Bush. Nope. They have the title of president. All right. Okay, Dominic, say it out loud and proud. It is George Washington.
How does this relate to your lesson?
You'll see in a moment. Let's do one more. I'm sorry, ladies. I should have put a little bit more variety in here. Famous? Caucasian. It's not Johnny Depp. Male. I should have put behind here with this clue, best looking coach award. Who would it be then? I'm glad you know, Will. It would be our Browns coach, Kevin Stefanski. Is that how you? Stefanski. He won the best looking NFL coach award. It was between him and some guy out in the west side of the country. Yeah, but Kevin won. Go Kevin.
Tom Brady. Tom Brady. Baker Mayfield.
It is Baker Mayfield. And the best thing I've ever heard, the little meme, the best meme I've heard about Baker is, all my brownies needed was a baker. Get it? And according to Carson Forte, because that's how you have to say his name, because, you know, that's what it is musically. It's a thing. You have to say it like that. So when you see him, say it like that. I love the little joke about this guy takes his new girlfriend to the football game. And after the game, she's like, I just don't understand the game. Why are those men fighting over a tiny little quarter? And the boyfriend's like, I don't know what you're talking about. She goes, well, there's all these people in the stands watching these grown men fight over a quarter because all they scream is, get that quarterback, get the quarterback. All right. That didn't make you smile at least? Will's smiling, I can tell. All right, so here we go. The reason we played that game is because sometimes if you're describing a person, you need more than one adjective to know who they are. Equally so, when you have a data set, you need more than a measure of center. Because sometimes data sets have exactly the same measure of center, but there are very, very different data sets. So always remember that a good thing is to plot your data. Always plot your data. Oh yeah, Mr. Forte wasn't participating in the pajamas game today.
Oh
Yeah. I don't know, what's his problem? His jeans didn't even look as nice as the pajamas.
yeah. They wanted to get me to wear a shirt and tie too, but I didn't want to do that. So.
Yeah, he didn't either. So you guys are just too good to be with the rest of the team? Is that what it is?
I just didn't want to. I didn't want to do that.
I'm just teasing. Anyway, speaking of which, Jameson just reminded me, like 300 came in. You are welcome anytime you wish to take a nose swing, okay? And I touched my nose with this one, so I'll bring it back over here because nobody wants to use the one that I touched. Anyway, you're welcome to take those anytime you need one, or I can deliver them to you. They're not good for the ones that are reusable masks because you should already have those in there. Poor D. Crames is fighting with a boy that thinks it's hysterical to wear his reusable mask upside down. So therefore, it's always falling down under his nose. And I just say, Debbie, God bless you, that you're still being able to have the patience to teach the algebra students. Because I told Jeremy, what's his last name? He was just our principal a few years ago, McDevitt. I told Jeremy, said, I need a break, because I used to teach like 5 years ago. For the first 25 years of my teaching career, I taught what we called algebra, or topics in algebra and geometry part 2. I taught a class like that my whole career, except for the last 5 or 7, I don't know, 5 to 7 years, and I've just run out of patience. Can't deal with their tomfoolery, as I would call it. But somehow, Debbie Kramer, she keeps on going. Like, she's teaching 3 preps right now and BC calculus. So her first two preps take all of her energy. They just suck it dry because of basically their behavior and lack of motivation. And then she teaches BC calculus, which sucks your brain dry because it's AP or BC calculus. It's kind of supposed to be hard. All right, so where was I? Standard deviation. We need measures of spread, and standard deviation is the most sought after measure of spread. By the way, it's called standard deviation because it can apply to any statistic. In AP statistics in high school, we concentrate on the mean most of the time. But you can find the standard deviation for the maximums. You can find the standard deviation for the minimums. You can find the standard deviation of the standard deviations. That's called analysis of variance, by the way, ANOVA. It's a standard deviation of the variances, which is basically the square of the standard deviations. But it's not called the mean deviation and the minimum deviation. It's called the standard deviation because it applies to all kinds of things. In fact, you can find standard deviations in least squares regression, but then you're not finding the deviation of a point. They're called something else. They're not called deviations in chapter 3, least squares regression. They're called something that begins with an R. E. S. I. Residuals. Because now you're doing the distance from that least squares regression line. So when we get to two sets of data with a relationship, we don't talk about the mean as the balance point, as the average. It's the least squares regression line that's now our average or our standard, which we deviate from. All right, if all of the points are at 5, what is the standard deviation? 0, because do they deviate from the mean? Not at all. Standard deviation, when I first started teaching, used to be STD, but then that became something else in a different topic. So now it's STDEV, or we have two symbols. We have sigma sub x and S sub x. And those, in both cases here, would be 0. What's the difference? Well, stay tuned and come back for class in a couple of weeks, and we'll talk about the difference of those. Okay, how do we measure standard deviation? Well, for this guy, that middle point has no deviations, and then we have 2 deviations out this way, and we have 3 standard deviations out that way, but we also have 2 standard deviations negative and 3 longer negatives. And guess what happens when you add up all those deviations? Which is a fancy way of saying subtraction. Jameson?
0.
Yeah, they add to 0. Over here, this guy has no deviation. That one has a positive, a bigger positive, a bigger positive, negative, a bigger negative, a negative, bigger negative. And Jameson, they still add up to 0. So, to find the standard deviation, you have to do more than just calculate deviations. So there's another data set, but the points aren't all the same distances. This is the mean. This has a positive standard deviation, positive, positive, a really big positive. This has a negative, and a much bigger negative. And if you combine all of those integer distances, it would add to, Jameson?
0.
There you go. So does anybody remember such a sad situation? We made you do this by hand twice in chapter 1 of Honor Statistics. And I'm going to make you do it one more time because I want you to understand how to calculate the standard deviation and that it's all about how far away you are from the mean. All right, and so Caden and Ainsley are expected to pay attention now, and the rest of you can pick up a pencil finally. And get your calculators warmed up, get your fingers warmed up. Who needs a graphing calculator? Anybody? Oh, that's right, that's first block. They didn't ask today, I wonder if they have them. Okay, This mask was made by a friend and I like it, except for it has the pocket at the top and that's like driving me nuts. I might have to put on a new mask. These masks are amazing. They're supposed to be even more protective than the N95s and you can wash them and they're really lightweight. The problem is they get little fuzzies in here and then that tickles my nose. So while it's nice for talking, it tickles. Ain't nobody got time for the tickle. All right. Yeah, I don't think I can do that one today either. Here's my bee mask that I made myself. Maybe we'll change to that one. All right.
Are you getting the vaccine today?
I'm getting the vaccine, and my daddy got vaccinated last night. God bless him. I just came out of my one appointment, and my phone had a text message from the discount drug mart. You know, discount double check drug mart. Oh, that's discount drug mart saves you the run around. Sorry, guys, quoting Aaron Rodgers there for a moment. So who's in the Super Bowl? I should know this, but after the Browns got eliminated, I didn't pay any attention. Who?
Chiefs and Bucks.
Chiefs and Bucks. So it's not the Green Bay, huh? So it's not the All-State versus whatever bowl that they were talking about. Pardon?
State Farm.
State Farm. Is Aaron Rodgers State Farm?
Yeah.
And then Patrick is,
State Farm.
oh, is he?
Yeah, they're
He's the,
Thanks for getting me the
I
good
think they were
deal.
talking about the progressive versus.
oh yeah, Progressive. Okay. All right, so here we go. I think it is extremely helpful, although not required, for you to put these in order. So make sure your phones are stowed because I will come and smash them. I will pull a John Torma and I will smash your phone. Not really. 22, 29, 33. What's next? 57. Ooh, some people didn't do very well on this test. 62. Tell me if I'm doing it wrong. Then we have 81.99. Ooh. See? I can't be trusted. 75, 81, 99, 100, and 102. Bonus land. Yay! All right, so how do we find the mean? I would ask Adam, but he's not in this class, he's next class. We add them up and we divide by, I think there's 10. That's, by the way, what little n stands for, how many are in the sample. And so you guys are going to do that, and I'm going to randomly select a person. And the mean is where it would balance. Like if you had all these values on a huge stick, and you put a penny where those values are, they would balance at this number. And I believe this is a nice number because then we can subtract much easier. All right, do we have it, somebody? That somebody is Mr. Pollock.
66.6.
I got 660 as my total. Anybody else get 660?
Oh, yeah, thanks.
And then we have to divide it by 10. So yeah, 66 is my mean. Okay, now we get to start such a sad situation because the such stands for subtract. S-U-S-U-B, T-R-A-C-T. So I'm going to do 22 minus 66. I think I can do most of these in my head. That's negative 44. 29 minus 66, just add or take away 5 from that. Is that or no, take away 7 from that. It's 30 what? 37. 33 minus 66, I can do that one. 33 negative. 57 minus 66, is that negative 9? 62 minus 66, that's negative 4. 75 minus 66 is positive 9. 81 minus 66, okay. What? 15, thank you. 99 minus 66, I got that one, it's 33 positive. 100 minus 66, well, that's just one more, that's 34 positive. And 102 minus 66 is 36. All right, and guess what happens? And Jameson isn't allowed to answer this, somebody else gets to. Hannah, what happens if I add up all those integers? Yep. And if you don't trust us, you can do that, but really this adds up to 0. So that creates a problem. That creates a conundrum. And the conundrum is, I have how much I'm differing from my balance point, from my mean, but now how do I quantify that? Because I can't just add it together. Well, mathematicians have two obvious choices as to how to get rid of negative signs. One is called absolute value. There actually is a statistic called the MAD, the mean absolute deviation. Supposedly, it's being taught in our elementary schools. At least it's in the curriculum, the new curriculum that started 5 years ago, but they probably never get to it. And to be quite honest, most elementary math teachers are not really trained in much statistics, although that's changing. Because some of you, I think, I have a couple people in class, and I think it was either this class or last class, who said that they wanted to go into elementary teaching. So that's really good. One of my best AP students, AP Stat students, a couple of my best AP Stat students have been people who are going into, I got this, careers that really don't have a whole lot to do with statistics. Madison Spacuzza, whose dad used to be the president of our school board, no, not dad, grandfather, Jerry Marino. She's in elementary ed, and then Katie Smith is in Cincinnati, and she's majoring in clarinet. And she was one of my best AP Stat students from the past, too. You never know when statistics will help you. Okay, so we've done such. Now we have to start the SAD, and the first part is to square. So I don't know what 44, 37, and 33 squared are, but I do know that negative 9 is 81, 16, 81, 225, and that's the extent of my brain remembering. So Val is going to do negative 44 squared. Alexa, you got the 37. Maddie, you got the 33. Allison, you got the 34. And Amelia, you got the 36. And how did those all end up being females? I don't know. Okay. Do we have the 44 yet?
1,136.
Excellent. And the 37?
1,369.
69?
Yeah.
Okay. The 33?
1,089.
1,089?
Mm-hmm.
And guess what? We get to use that one again for positive 33. And thank you all, ladies, for not telling me it's negative, because your calculator, unless you use parentheses, will tell you that it's negative, right? And I don't care if you just plug in negative 44 squared in your calculator. At least they knew not to say negative 1,936. So yay, you guys. Okay, the 34.
1,156.
Thank you. And the 36?
1,296.
Thank you. So that's the such. A really doesn't have anything, but it's the S of sad. Now the A of sad tells you to add them all up. So everybody's going to do that. And it has something in common with our date today. That's all I'm going to say. So don't say the answer, but who knows why I said it has something in common with our date? Joe?
Palindrome.
It's a palindrome. All right. So what palindrome is it, Mr. Parker?
8,338.
8,338. All right, so that's the A of sad, and now the D of sad tells us to divide, but here is where it gets a little weird. We divide by 9, not 10. What the heck is that about? Well, it's called degrees of freedom, and the AP Stat guy has an amazing video about it. I will find it and post it. If it's short, we'll watch it next week. If it's over 5 or 6 minutes, I will highly recommend it. So yeah, and if I do that divided by 9, I get what, Alexis?
296.4 repeated.
That is something special called the variance.
Oh, I said that very wrong. 926.
So what is it if you divide by 9?
926.4 repeated.
926.4 repeated. You could have said that and I wrote the wrong thing down. I don't know. Everybody agree with her? And now we have to take the square root of the repeater thing. Caden, what do you get?
30.4.
Yep, 30.4 repeating. That is our standard deviation. Now, Ainsley and Caden will understand in a second why the variance is so important. And it comes from stuff I told you like earlier this month, like sometimes you can't play with standard deviations. Does that ring a bell to both of you? Okay, and I'll explain that to the rest of us. So that's how you calculate the standard deviation. Deviation means a difference. How much is this little point differing? I kind of like that word. How much is this little point differing from its standard, which we're talking about the mean as the standard right now? If you go up and look at this, some points differ more than the 30.4. Some points differ much less than the 30.4. That's why when we interpret it, we say that it is the typical amount. It's not the exact amount. It's actually the average of all the amounts. A weird average because we're dividing by n-1. And we don't say it's the average amount you differ from the average, because then you're using the same vocabulary word twice, and that's kind of frowned upon. All right. Any questions on how you do that by hand? Will we ever have to do it again? Not in my class. But it really helps to understand what's going on. And you'll see why in a minute. Okay. So, 4 important points pertaining to the standard deviation. Why do we square instead of finding the absolute value? This isn't in your packets, you just have to pay attention. And to be honest, most of your math teachers, except for Mrs. Bogger and I'm going to throw out probably D. Kramer, maybe, and of course Coltis. Coltis has one of those brains that you tell him once and he remembers it forever. I was like 3 or 4 years away from entering Kenston School District and maybe having to teach Mr. Coltis. How about that? Whew! I don't know how that would have gone. I mean, he's a really good friend of mine now, but smart people that don't do a whole lot kind of sometimes get under my skin. He did used to hold clinics at his house after school to teach people calculus. Because the guy that taught calculus when I first got here, his name was John Rowley, and he would do this. Good morning, class. And if you have Mr. Coltis, you can ask him. Good morning, class. Are there any questions on last night's homework? Seeing that we have no questions, we can start on tonight's homework. They're on the board. Come up if you have a question. So Mr. Coltis would teach anybody who wanted to come after school. He would because he could read the book and teach himself and then teach the class. Mr. Rowley really did not teach a whole lot. I think his excuse was, well, these kids are smart enough, they should be able to teach themselves. They're in calculus, damn it. Okay. God bless him. I like the man. My third year at Kenston High School, he had a heart attack in November and didn't come back to school between Thanksgiving and Christmas. And they asked all the math teachers, does one of you want to pick up his calc class for this 3-week period? Me being the stupid, naive, new rookie teacher, thought, heck, if I do this, they'll give me better classes next year. So it was shells and discs method. Anybody know what I'm talking about? Like double integration, shells and discs. Have you done that yet? Anybody know what I'm talking about? Rotating around the axes?
Yeah.
Okay. That's what I got to teach. So I prepped and I planned and I gave up my planning period to teach his calculus class. And I gave him a test and I graded all the tests and I set all the papers on his desk and he came into class the first day and went like this. And threw all their tests away and everything I did, and I cried. I went home and I said, Chris, you just threw it all away. None of it counted. And Chris said, of course he did. Think he's going to take your work? Did I get to teach better classes the next year? No. So much for that. I don't know what the moral is in that lesson, but I learned it. All right, here we go. I think some of you have seen this, but maybe some of you have not. Because sometimes I get this far and sometimes I don't, but probably Mrs. Bogger does. All right. If I were going to graph, give me a second, I got this. If I were going to graph x squared, I'm hoping, that's why Algebra 2 is a prerequisite for statistics, that you would get, except for I think there's one in number 7 for some reason all the way down here. Did I turn that bad boy off? Yeah. Okay. Zoom square. Yeah, that's not good. Zoom standard and now zoom square. If I were going to graph y equal x squared, it's a parabola, right? Vertex is at 0, 0. There's one low point on a parabola. All good. Okay. What if I said I was going to graph the absolute value of x? Let's graph the absolute value of x. I got this, math, num, absolute value, x. What's that going to look like? I call it a stressed out parabola. Somebody took the nice arms and went, because it functions just like a parabola, right? When you move it around, when you move its vertex around. See, I have taught regular math classes once upon a time. So here is my absolute value. How many bottom points does it have? 1. So if we only had one piece of data in a data set ever, like, all right, 12. That's my data set, 12. Well, the mean and the median and the mode are all 12. The standard deviation is 0. If we didn't ever have more than one piece of data in a data set, we wouldn't have this course. And that would be easy. But let me show you what happens even just with 2 pieces of data. Okay. So who knows what's going to happen when I graph parentheses x minus 3 to quantity squared. Something's going to happen to that parabola. It's sitting at 0, 0. It's either going to move up 3, down 3, left 3, or right 3. Right 3 or left 3. Who knows what it's going to move? Because it's lying to you, right? Your math teachers ever say that? Like, this isn't really true. It says minus 3, but it's really going positive 3. All right? So that would be like having a data point of 3. Okay? Look what happens, and you guys agree that the same thing would happen down here with, if I just had, I'll put it down here. Put in plus 3. And did I take the, come on, go away. All right, there is my B. Oh, I put in plus 3 there. I meant to put in minus 3. That's okay, same thing. It has one lowest minimum point. All right, look what happens when I combine two parabolas, which is like squaring data like we do with the standard deviation. Let me put that in, and let me put plus parentheses x minus 5 close parentheses squared. When I add two parabolas together, do you see it still has a lowest vertex point? It still has a vertex, a minimum point. Parabolas can have a maximum point, Mrs. Garrett, if you tip them over. Yeah, I know that. We're not talking about that right now. Watch what happens, though, when you add two absolute values together. And some of you have seen this before, and some of you haven't. And this is a huge problem. That's a flat spot. That's not a vertex. That is unacceptable in statistics, because statisticians are always about doing the least, the best. And where is the least x value? That's the wrong thing to say. I want to find the y value that's the smallest and find its corresponding x. Can I do that with this graph? Where is x the lowest? Well, on that flat spot. Let me change my window a little bit for you. I'll change this to -5 and this to, we'll leave that at, well, I'll change it to 10. Don't really need the stuff down below here. Sorry, that should be -2. Okay. Where is the least on there? How many least y values are there, by the way? Who knows? 3? How many points are there on a segment? Infinite. There are an infinite number of minimum y values. There's no way I can find the x that goes with the minimum y, because there's an infinite number of them. You're not allowed to have that. But if you do this with the squares, guess what happens? Exactly what you would expect. That still has a vertex. No, it doesn't. It looks like it's a flat point. I know it does look flat. That's just because of the window I have. So let me do zoom standard. Now you can kind of see that that is actually one point. It's a vertex. So we use squaring for statistics because it gives us a true minimum value. All right? There you go. We don't do the MAD, which would look like this. We do the standard deviation. All right, why is the variance so important? Because you learned in Algebra 2 that the square root of 25 does not equal the square root of 9 plus the square root of 16. You would have to keep the 9 and the 16 under the square root house, right? To make that be equal. So sometimes you can't play with standard deviations. You can only play with variances. And if you had statistics just If you had honor statistics recently, you understand what that statement is. And if you don't, you will before we get to two-sample inference. Some of the deviations always adds to 0. We established that fact earlier. And last fact, before we take a break, what's this n-1 thing? Well, I told you that the AP Stat guy really does have an awesome video about this, but it's kind of like the mathematics behind it is kind of like this example. Suppose that you know that I got a 92% average on the 5 tests in my math class, which is exactly what I need to have an A and not an A minus. So I'm going to let you choose what we got on our tests. All right, so Nick, what do you want to say I got on my first test?
64.
64. Well, if I'm going to average 92, how far in the hole am I? Down how much? Aren't I down 32? I'm down 32 points, yes? 28? Oh, yeah. If it was 62, it'd be 30. I went the wrong way. Yep, thank you for correcting my arithmetical. All right, Joe, what did I get on my next test?
A 20.
A 20. All right, so now that test alone is down, what, 70? 72? Is that right? So I'm down a total of 100 points, right? I have a 100-point deficit. All right, Joey, what did we get on the next test?
A 112.
All right, I got some bonus, which put me up what? Well, just this test alone is how much above the average? 20, right? So now I'm only in the hole a total of 80 points. All right. Leah, what did we get on the fourth test? A 99, which gave me 7 to spare. So now I'm only down 73 points. If I truly did average a 92, does Nick have any freedom of what we have to score on our last test? There's no freedom. Nick has no freedom. He's going to have to pull an impossible feat and get a 165, right? Doesn't 165 average us out to 92? So when you use one statistic to calculate another, you lose a bit of freedom in the formula, and that's kind of like what the math is going on behind the standard deviation, a little bit. That's the idea of degrees of freedom. If you already know the average, then this would give you 4 degrees of freedom because you've lost your 5th one. Sort of something like that. All right. We're going to take a bit of a break here, but before we do, let me show you this picture. Here's a couple little funny pie charts. I found out that actually some of you do look at the cereal box when you eat your breakfast. You're not on your phone. Back in my day, that you either talked to your sisters or you looked at the cereal box. So this is things I read at breakfast, the cereal box, the mail, the newspaper, or a book. So these are the kind of things, like I like these types of things. I'm kind of looking for things that are new out there, but you can still get bonus points for turning in these things. Then this one says, what happens when a piece of ice falls on the floor? Do you pick it up or do you kick it under the fridge so nobody knows? And this says most people kick it under the fridge. That was me until I got my brand new kitchen with my highly expensive, looks like hardwood, but it's really a laminate floor that we paid $15,000 for. So now I don't kick that under the fridge. Because I don't want to damage the pretend wood that's under there. And there's a lot of cobwebs and fuzz, and when that water hits it, then it solidifies on the floor, and guess who has to clean that up when it's spring cleaning time and you move the refrigerator out? Yeah, so when it's your job, you kind of tend not to add to the gunk. All right? And then I really, truly do like this one. This is the kind of stuff I really like. Like, I might give you 2 bonus points if you came up with something that was on this line. I think that's pretty funny. Statistics show that teen pregnancies drop drastically after the age of 20. Yep. All right. One last one. This is also the type of thing that I'm looking for. And somebody, I think most of you have seen this one. This was actually presented to one of my honor statistics students when she went to her college orientation with her parents. And she texted me that with that saying at the top, I don't think this is right. And I texted her back and said, maybe you shouldn't choose this as your college if they can't even do basic statistics. They truly don't know what 1/3 looks like in a pie chart. All right. Does anybody need to use the facilities? That means bathroom. Anybody? Okay, go ahead and go. The rest of us should stand up. What are we going to do? Does anybody have a brain break they want to do that we haven't done yet? I mean, we've only done 2. Oh, I know what we can do. You guys have done this before if you had me, but it still works. All right. We're going to make Rourke do this too. So who do you want to watch you, Stephen or Elena?
Doesn't matter.
All right. Stephen's going to make sure Rourke's doing this too. Can you see me right here? Rourke?
Yeah, I can.
Okay. Put your fingers up in the air. I guess I'm going to turn backwards. And we're going to make triangles. Ready? 1, 2, 3. 1, 2, 3. 1, 2, 3. Now we're going to make squares. 1, 2, 3, 4. 1, 2, 3, 4. How about circles going counterclockwise? And circles going clockwise. All right. Now, can we make circles going the opposite ways? Impossible?
I thought you meant like one going.
See, I can do this one too, Jameson. Look at me. Okay, now let's do squares going opposite.
That's not possible.
It's not the same way.
Oh, it's just, it's not like the set out either side. Okay.
Now, triangles is kind of tricky. That might be impossible. Ready? 1, 2, 3. 1, 2, 3. Yeah, if we started at different places, you're right, Jameson, that would be a little hard. Let's see. 1,
Right triangles?
2. Oh, that one's not so bad. What if I start down here? 1, 2. I'm making mine equilateral, can't you tell? 3. 1, 2, 3. All right. That's called double doodles. It's supposed to do something. They actually,
I'm thinking.
oh, if you go like this and then you go like, yeah, that might be, I don't know.
Yeah, but I get it.
All right, that was fun. Go ahead and take a seat. Anybody figure out the finger thing yet? Anybody work on that?
I'm really good at it.
Now you start like this.
No, I do. I'm not good at it.
If anybody can do that spinny pencil thing on their pointer finger, I think this is the pointer finger. I gotta figure that out. Somebody I sat across from once at the reading could do this. And without looking, when he was contemplating a kid's response, he'd sit there like this and he'd go like this, and then he'd go and catch it. Like it would seriously go up in the air, spin around a couple times, and land back in his hand, and he wasn't even looking. He just went. And pretty soon, but it was like, it wasn't like a toss. He would just be sitting there with his hand, and he'd go, but it would go around a couple times. And he wouldn't have to move his hand to catch it. So pretty soon, there were 8 of us in the room that were worker bees. And I nudged my partner and I said, look at that guy, look at his pencil. How does he do that? And pretty soon, like all 15 of us were watching him do his pencil thing. And he looks up and he's like, what? We're like, you gotta teach us that. How do you do that? He's like, oh, I don't know, I've been practicing for years. I'm like, yeah, probably. But that was the coolest thing I ever saw anybody do to whatever that's called. But this thing that like some of you can do that spins around like that, that's pretty cool too. I can't do that. Can anybody juggle? My husband can juggle. I'm impressed with that. If you haven't tried, yeah, with 3, like, all right. This is not a good object to juggle with. I need like balls or something. That's as good as I can do. And for gym class, you had to be able to do 12 rotations. I did not get an A in juggling. I don't even think I got a B or a C.
Why?
Because there were like 15 things you could choose to do, and you had to do 12 of them perfectly to get the A. And I don't know what the other 3 things were, but they were something that I just couldn't do. And I worked on my juggling, and it just wasn't happening. We did gymnastics in gym class, too. Is anybody in here in the gymnastics team? I have Claire, first block. Yeah, we did uneven bars in gym class. I could do, I don't know if it was called a basket drop or something, like you hang your legs over the lowest one and you hold on to the highest one and then you pull yourself up and you let go and you go. And the first time it was like, oh my God, I'm really gonna do this? I'm so nervous. And then you do it once and you're like, holy cow, gravity just takes right over and there you are. It's the same thing I used to could on the knee board behind the boat, do a 360. But I don't think I'm brave enough now. Because I know how much my shoulder's gonna hurt after I do it. Because when you let go, man, you have to be really, really strong to grab it and really, really strong to turn around, and I ain't that strong anymore. I wanted to learn how to barefoot ski until I heard that the back of your legs are gonna turn black and blue. I'm like, okay, I guess I don't need to learn that bad. Has anybody ever barefooted? On a lake, not in the cold snow. No? It'd be so cool to be able to do, but the spray of the water and the force, I guess it just turns the inner parts of your legs and the back of your legs totally black and blue. I don't need to do it that bad. Alrighty. On to other things. Yeah, I don't want you. I want this. Here we go. Okay, so we have resistant and non-resistant measures. Most of the time we deal with non-resistant measures and outliers are deaf to statistics. When we get to inference, outliers are deaf to statistics. You need this for homework and then you're gonna do this and the D's. Really only the first front and back page is due. Instead of taking your own notes, you just fill them in here. But if you wanna do the whole thing, it will eventually be next week. All right, who remembers this problem? I am going to tie in, and this is all being recorded in case you want to watch a few moments of this, Amelia. If you want to catch the last part. I think I did the recording. So they get to watch our brain break. Woo-hoo. Yes, sir.
Is there A skips in this class?
Yes, eventually, some. But I try to really limit the amount of homework I give in the first place. So that's why it's not quite the thing. But yeah, I mean, right now we're doing a review, and ain't nobody skipping that.
Yeah.
Okay. If I gave you this set of data and asked you to find the mean, by the way, don't start filling this out because you're not really going to do all of this. This is just stuff I was thinking about last night to tie yesterday's look of, I have no clue what you're talking about, to, oh, that's what you were talking about, okay? So if I give you this data set, we can add them all up and then divide by 50 to find the mean. That's how we do it, right? But some of you might say, I think there's a shortcut, Mrs. Garrett, because look, there are 1, 2, 3, 4, 5, 6, 7 zeros, and 1, 2, 3, 4, 5, 6, 7 ones, and 1, 2, 3, 4, 5, 6 twos, 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 fours. 1, 2, 3, 4, 5, 6. Boy, you like the number 7. Fives. 1, 2, 3, 4, 5, 6, 7 sixes. 1 7. 1 8. And 4 nines. You can just do it that way, Mrs. Garrett. Get your total and divide by 50. And that's how we introduced this in honor statistics. Even last year in the spring, if you watched the video, we did this. I checked. But this is a random variable, and things repeat a lot. So we can take this, and if we just take that denominator of 50 and move it right out here with the coefficient, we get what we were talking about yesterday with the camcorder. Because I can put this into this distribution of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and make this be 7/50ths, 7/50ths. What was this? 6? I can go look, it's right here. 6/50ths, 1/50th, 9/50ths. And do you agree that when I do the top times the bottom, plus the top times the bottom, that dance that we were doing yesterday, it would work out to be the same thing that we started out doing in the first place? So that's how we got to yesterday's find the mean by doing the top times the bottom stuff. Okay? That's the link that I didn't have ready to give you yesterday because I didn't have this worksheet in front of you. And if we go down a little bit, this is some of the stuff we did yesterday that wasn't too upsetting. But this is where we started falling apart. And you guys have a rule sheet, which I'll bring up in a second. But the expected value, when it's in a probability distribution table, there's a shortcut to finding the mean. And that's just doing all of the x's times their probabilities. That's what this formula means. And this is how we do that. We did it yesterday. And that's how we interpret it. And that is my writing, but it's how my writing looked like when I did it on a tablet at home. Like D. Kramer has a tablet and John Holcroft has a tablet. And John is phenomenal. I don't know how he does it so neatly. I mean, that's at the end of that whole quarter of teaching from my office closet at my house. I felt like that's all I did last year, fourth quarter. I woke up, sat in front of my computer, and fell into bed exhausted and did it for like 9 weeks. And so when we were coming back to school this year, I was like, I can't do it again. I can't do it. I was close to taking a year off. Like, I was like this close. But I didn't take him back. I don't know if that's good for you or bad for you, but I'm here, so just deal with it. All right. So that's why the mean works like it does, okay? Does that make people feel a little bit better? Like there's a method to that and it really works? And now, after everything we did at the beginning of this class, I'm hoping that you understand how this variance thing works. Why we subtract and why we square. Yeah, but there's no n-1 thing with this, Mrs. Garrett. You're right. This one is missing that uncomfortableness. But you're still dividing by multiplying by the probability when you're done. And you're still square rooting. So hopefully you understand that formula a little bit better now too. And if you find that page, chapter 5, that you collected from the back, could you guys find that? Put it in a slip cover. It was purplish if you brought it from here. On the front side of this, you have the chapter 5 stuff. And on the back side of it, you have the chapter 6 stuff. And it looks like this. Where the heck did I put this? Where'd you go? So if you could find this page, we're going to write something on it. And I'm going to get rid of that bottom half, you know. So that's what I want you to find. And we're going to we're going to put some things on this formula. And we're also going to put some things on this formula. So you can write them bigger if you're not a tiny writer. There's a lot of room to your upper right on this paper. And what we are going to write is this. Expected value equals add all the pieces, each outcome times the probability of each outcome. So what this is really meaning, this is called the expected value, or the mean. That's what the mu equals. And I guess if you're from Greece, if you are of Greek ethnicity, if you speak Greek, that is not mu, it's me. But then that totally ruins me telling you mu can do it. And everybody else in this country and all statisticians in this country pronounce that mu, so it's mu. Like a kitty cat. Meow. All right, so what does this mean to do? Oh, that's green. I don't want it to be green. We'll make it blue still. Add up each piece. I was really going to say product because it's a sum of a bunch of products, because product means to multiply. And what's the x sub I stand for? each individual, they're called outcomes of the random phenomenon. I'm not going to put that in, but like balls floating up in the air thing, or you could do roll, like when you roll a dice, the outcomes are 1, 2, 3, 4, 5, or 6. That's an outcome. And the piece of I that you're multiplying that by, what does the piece of I stand for? Probability of each outcome. Sorry, that's kind of messier than what I had on that other page, but those are the pieces parts. Just so you know, because you get that, by the way, the reason we're doing this is because that formula that I wrote in green right there is on your fluorescent green page that the AP people let you have. It's the first thing in the table if you're looking at your fluorescent green formula. So I kind of want you to know why it's there and what it means. Because it means the mean. You know what I mean? All right, what about this? This is the variance. So I have to remember to square root that to get to the standard deviation. Again, that means to sum it all up. Each little piece is part. What's x of I stand for again? Yep, I'm just going to put each outcome now because I put individual up above, and so yeah. Oh, what's mu of x? The mean that you calculated just a moment ago. We all should understand why we have to square the differences, because if I didn't square the differences, guess what this whole thing would add up to? 0. And then you don't have a measure of how far apart things are. And piece of I is the probability of each outcome. So if it's a fair die, each probability will be 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. But if it's a deck of cards and you're pulling out 2 cards and, okay, that's, never mind. If it's 2 die and you're rolling 2 and adding it together, then the sum of 2 only happens 1 out of 36 times. And what happens the most frequently when you roll 2 die? 7. And that happens 6 out of 36 times. All right. All the rest of the stuff on this page down below here. Oh, by the way, the standard deviation, this is on your green sheet as well. The stuff down below there is not on your green sheet. However, on your green sheet below this mean and standard deviation is what we're studying next week. And the stuff on your purple sheet down below here, we will go over that, but we're going to go over it when it makes more sense to go over it, which will not be probably for a month. All right. Last thing on the list. This page right here, check your understanding. Let's just do 1 and 2 right now. Well, let's just not do it. We'll do that next week. It's Friday, and we don't want to do it. Okay. Me either. So, what is your homework? Well, your homework, and Rourke, you're going to have to print this out or use extra paper to, I'll show you in a minute. Your homework is to start taking notes on section 3, which is enormous. Yes, you did, and I'll probably hand it to Andrew, even though right now I'm remembering not to. And some of you know what this is all about if you had honor statistics last spring, because this is what we went to instead of notes quizzes. Because let's just be open and honest. I almost did it easily, but I didn't. We all know that virtual assessments are a virtual cheating fest for some of us. And I refuse. I just refuse. I refuse to punish those of you that have moral integrity and are not going to cheat. And I refuse to reward those of you who really just want the best grade you can get, and you will cheat out to wazoo. Not that anybody in here falls in that category. So this is what I want you to do. You have to do page 1 and 2. But, you know, if you look at it, page 1 and 2 has the most, like that's 2/3 of it. And if you do page 2 and 3 here, there's not quite as much. So all you're going to do is open your book and look for where it says binomial setting, which I think I can get the book open here in time. Just hang on. New tab, bring up the Practice of Statistics 5th edition. I am my own person. Pick my course. You guys only have one. You can do this if you don't have an electronic textbook, but you need your textbook. So if you didn't take your textbook home yet, take it home. All right. And this is why it says you have to use handwriting. Because I know that if you have the electronic textbook, you can just go like this. Okay, control copy. Let's go back to what I have in class. Control paste. Put that right here. Done. Go to the next one. You're not allowed to do that. You have to handwrite it in. This is called front loading. You're getting the vocabulary before I use it in my lesson. So you might have a tiny little bit of, oh, that's what that means when I read it. All right? And then the rest of that one, as you can see, let me show you. The 4 conditions are binary, independent, number, and success. And I already wrote, you got to copy the whole sentence or 2 down. This is a regurgitation assignment. Take it out of the book and put it onto the paper. What happens on Sunday at 9 o'clock when you discover, oh my gosh, I didn't bring my book home? You don't email the teacher and tell her. You call Alexis, or you call Kelsey, or Nick, or Dante and say, hey, did you take some pictures of this section in your book and text them to me because Mrs. Garrett told me to take my book home and I didn't listen? All right? So you need to take your book home to do this homework. All right? So you guys be on alert. Ainsley, too. And Elena and Alexis, if I didn't say it. The 6 of them are in charge of making sure you all do your homework. Sounds like a good idea to me. So what's this Joan of Arc stuff?
Oh, CYO.
All right. All right. Have a good one. Stay warm because it ain't supposed to be warm. You know what you need, Roar? Okay, have a good weekend, and we see you Monday? Excellent. Oh, I didn't even give you out your red folders. That's good, because now I don't have to collect them. So we did no, because now you would be at the place where you could maybe understand that a little more airplay and stuff. All right, so right now you just need to know that you can put my name in. Yep. You don't know of any. Oh, that's why I had you stay here. I remember it now. Okay, so this is specifically like experience 1, 2, and 3 on this front page is specifically about this class and the lesson materials, not like, oh, you put stickers on my test and it makes me feel good. No, not that kind of stuff. Like Oh, when we did this, I really like this. When we did water balloon bungee, because I think you got to. Like it really, I liked it because of thus and such.
Okay.
And then on the back, this is just like if they want to know your character, your leadership, like if you've done things outside of school.
Okay, sweet.
And the better you do that, the more impressive your letter will sound, should I have to write one. Okay? And I can send that to you electronically if you'd rather type it.
Do you mind if I take this to the library?
Absolutely not.
Okay, thank you.
Thank you.
And then I have a book,
Oh,
'cause I think I missed it. I was
so which book do you want? Go pick a good one.
Can I have the one with the cover on it? Or is it-
Yeah, no, I told that person to leave the cover on because then somebody would, okay, what is it? Oh, 0516?
Oh, first, yeah.
Okay.
And then, what is the statistics in life thing? I think I missed a little bit of the introduction.
All it is if you hear an interesting fact in the news, or if you are really interested in how this corona vaccine's working, or like, do you play any instruments or do any sports? So if you're really interested in some statistics in softball, like when I heard that on the radio about dogs sniffing for COVID, I was like, I gotta find out more about this. So I'm gonna look into the statistics of it. So I just want you to prepare something that's gonna take 2 or 3 minutes, like I heard about this and I looked it up and here's the statistics on it. Yeah, eventually. Like after next week we'll start. And I'll probably pick 2 or 3 people a week until the end of the quarter. And then we'll do it again for the next quarter. I just want people to know that there's statistics in places other than what I have interest in. Yes, sir.
I was gonna, I found the answer to the question I was asking yesterday.
Nice.
And you were on the right track.
Oh, good.
Yep.
That's good to know.
So here's the deal. If you have some sum of I items and you've got like some, again, I don't know. the
Some
correct-
function. Yeah.
Sorry?
Some function of
Some
the
function,
normals.
Normal, yeah. And then there's actually technically, in my situation, there's actually 2 of them multiplied together, but
Oh,
they're both mean 0, standard deviation 1.
okay.
Okay. But if you add them all up, apparently they're going to have a variance of I.
Huh.
Okay? Which means if I want to make the standard deviation of this to be 1, I
You
would
have to
divide by the
square root of I.
Yes. So that's where that came from. So it's like a
Leave
whole,
that up there.
Okay.
Yeah, it makes sense why you divide by the square root of I then. Cool.
Yep. So yeah, it's like just a whole bunch of samples and
You're multiplying them together.
yeah, two standard. I mean, that's probably not going to make a difference because I guess a standard distribution times standard distribution should be a standard distribution, and if it's got the same mean and standard.
Well, I know when you
deviation
add and subtract the standard distributions, they're still
there's standard
normal.
yes, but
Because we teach them like adding and subtracting and multiplying or adding constants, but we
Okay.
don't talk about multiplying to
yeah. Well, these
normal.
are like the most basic mean of
Okay.
0, standard deviation
Yeah.
of 1.
Those are yeah
Yeah.
standard normal curves.
And I think if you multiply them, you get just the same thing.
Hmm.
So that's probably irrelevant. But when you add them all up, I times, you get another one with variation of I, or variance of I. And then
Is that variance times I, or
the
is it
variance
actually of I?
Yeah, variance of I.
So if I is 10, the variance will be 10?
Supposedly. That's what I'm reading here. Because I guess that makes sense because what you're doing is like if you take a standard deviation or no, a standard curve
Mm-hmm.
and you stretch it vertically by say 10,
Yeah.
the variance is going to become, I think, 10.
Oh, because
Something like that.
if this, well, okay. So, okay. So if this is a standard normal curve, the standard deviation is 1.
Right.
So the variance would be 1 squared, which is still 1.
Correct.
But then if you multiply 1 times 1, you
It's
get 1.
still the same thing. Mhm.
So,
But when you add up a whole bunch of them, like if you do this times or plus itself, 100 or 1,000
Right.
times, you're going to get a big version of this stretched out.
okay, so the reason I was thinking it should be this, But that's just one.
Right,
So that
so it's a
doesn't
variance of I,
Right.
yeah.
But I wonder if you do other things, like if these aren't standard normal curves, if
Right.
it would be the times I,
Probably something like that.
something.
I don't know that one, but yeah,
Okay.
in my situation, we're just taking this.
Are you taking a graduate class or?
No, this is just my own research.
Okay,
This, like I said, this has to do with neural networks and computer programming.
okay,
So it's interesting to see like statistics and calculus pop up in these places, of course.
yeah,
I don't know much about stats. I know some calculus.
yeah,
So I told Debbie about this also. I'm like, hey, here's some cool application.
yeah.
So
No, that's interesting. I have not thought about it like that, but my son, I'm sure, because he's, like he said, and he was told, if you're really going to go into getting a graduate degree in statistics, you need to know your calculus and you need to know your computer programming.
Okay, cool. Yeah. And so yeah, the idea here is the programmer got to choose these to be standard,
Okay.
like this, but the result of which we want to be the same thing. We want it to have a standard deviation of 1, and therefore we divide by square root of I. Yeah.
Cool.
Yeah, and we want to keep it that standard.
Yes.
Mm-hmm. So there's the secret.
Excellent.
Mhm.
Thank you.
Thank you for your insight.
Yep.
Yeah, like I said,
I'm glad it was sort of on the right track.
Yeah. Yeah. I just don't know enough about stats to have made that connection.
Well, I don't really either. So,
Okay.
I mean, I know what I teach really well because this is year 20 for teaching this course.
Oh, okay.
I started in 2000 because Y2K was going to make it so I didn't have to prep for the second half.
Oh, okay.
But that didn't happen.
Right.
That's at least the joke I use.
Gotcha.
All right.
All right.
Have a good afternoon.
Thanks.
Yep. Bye-bye.